Imagine a future where humanity thrives, not just on Earth, but in massive rotating habitats floating in the vast expanse of space. The concept of living in an O'Neill cylinder, a colossal artificial habitat envisioned by physicist Gerard K. O'Neill, pushes the boundaries of our imagination and challenges our understanding of what human life could become. Could these spaceborne colonies be the next frontier for human civilization? Or are they merely the stuff of science fiction? The thought of entire communities residing in space stations sounds like a plot straight out of a sci-fi novel. Yet, with advancements in aerospace technology and a growing interest in space colonization, the dream of living in O'Neill cylinders is inching closer to reality. These habitats promise a new way of life, offering solutions to Earth's overpopulation issues and providing a fresh canvas for human potential. We stand at the brink of a new era in human history. As we look up at the night sky, the stars don't just represent distant suns, but potential homes. The idea of space colonies captures our collective imagination and fuels our ambition to explore the cosmos. But what exactly are O'Neill cylinders, and how feasible is it to build them? O'Neill cylinders are not just a flight of fancy, they are grounded in rigorous scientific principles. Proposed by Gerard K. O'Neill in the 1970s, these massive structures are designed to support human life in space. Each cylinder is a rotating habitat, generating artificial gravity through centrifugal force. This rotation allows inhabitants to experience a semblance of Earth's gravity, making long-term space living more viable. The design of an O'Neill cylinder is both ambitious and elegant. Picture a pair of cylinders, each 20 miles long and 4 miles in diameter, counter-rotating to cancel out gyroscopic forces. Inside, you would find lush landscapes, cities, and even bodies of water. The interior environment would be carefully controlled to mimic Earth's climate, complete with breathable air and a stable temperature. Constructing such a habitat would require advancements in materials science, energy production, and space logistics. The outer shell would need to be strong enough to withstand cosmic radiation and micrometeoroid impacts. Solar panels could provide energy, and a sophisticated life support system would recycle air and water. While the challenges are immense, the potential rewards are equally great. The concept of O'Neill cylinders invites us to rethink our place in the universe. It challenges us to envision a future where human ingenuity and determination can transform the void of space into thriving communities. As we delve deeper into this essay, we will explore the scientific foundations, daily life within these habitats, societal impacts, and the technological leaps required to make this vision a reality. Artificial gravity is a cornerstone of the O'Neill cylinder concept. Without gravity, long-term space habitation would be fraught with health issues, such as muscle atrophy and bone density loss. To create a livable environment, these cylinders utilize centrifugal force generated by rotation. But how does this work in practice? When we think of spinning objects, the centrifugal force pushes outward. In an O'Neill cylinder, this force acts as a substitute for Earth's gravity. The cylinder rotates around its axis, and the inhabitants live on the inner surface. This rotation creates a sensation of gravity, pulling everything towards the walls of the cylinder. The speed of rotation is crucial. Too fast, and the inhabitants might feel dizzy; too slow, and the gravity effect would be too weak. The rotational speed needed to simulate Earth-like gravity is about 2 RPM, revolutions per minute. Achieving this balance ensures that inhabitants experience a comfortable gravitational pull, similar to what they are used to on Earth. This artificial gravity supports normal physiological functions, allowing people to walk, exercise, and perform daily activities without the debilitating effects of microgravity. However, it's not just about mimicking gravity. The rotational environment affects everything from fluid dynamics to plant growth. Scientists must study and adapt agricultural practices, water distribution systems, and even architecture to function within this rotating habitat. This scientific exploration into artificial gravity is a blend of physics, engineering, and biology, pushing the boundaries of our current knowledge. Designing an O'Neill cylinder is a monumental engineering challenge. The structure must withstand rotation, vacuum, and micrometeoroids. Modern materials science offers promising solutions. Composite materials provide strength while being lightweight. The exterior needs a protective layer against micrometeoroids. Engineers propose a modular approach for scalability. Integrating nature elements supports human life comfortably. The design is a testament to human ingenuity and adaptability. Life support systems are the heart of an O'Neill cylinder, ensuring a stable environment for human life. They manage air, water, food, and waste, mirroring Earth's natural cycles. Creating a self-sustaining ecosystem is essential for long-term habitation. Air must be kept breathable, primarily nitrogen and oxygen. Continuous monitoring prevents harmful gas buildup. Advanced filtration systems maintain air quality. Plants absorb carbon dioxide and release oxygen. Water must be recycled efficiently. Technologies ensure clean water availability. Hydroponics allow efficient food production. Waste management is crucial for sustainability. Sustainability is fundamental in an O'Neill cylinder with energy production at its core. Efficient energy generation and management support life systems and activities. Solar power is the most viable energy source in space. Panels capture sunlight, converting it into electricity. Advances in photovoltaic technology enhance efficiency. Energy storage systems ensure a stable supply. Integrating multiple sources enhances resilience. Smart grids optimize consumption and reduce wastage. Sustainable energy is vital for O'Neill cylinder's viability. Life inside an O'Neill cylinder would present a unique blend of the familiar and the extraordinary. With artificial gravity created by the cylinder's rotation, inhabitants would experience a sensation much like that of Earth. The day would begin with the familiar routine of waking up, showering, and having breakfast, but set against a backdrop of a breathtaking space habitat. Imagine waking up to a view of a lush, green landscape stretching above you. Thanks to the cylindrical nature of the habitat, the artificial gravity ensures you can walk, run, and engage in physical activities just as you would on Earth. This is crucial for maintaining bone density and muscle strength. Workdays would vary depending on one's profession, but the environment would be designed to support productivity and well-being. Housing would likely be modular and customizable, offering a range of living spaces from compact apartments to spacious family homes. These living quarters would be equipped with advanced smart technology to manage lighting, temperature, and even personal health monitoring. The community layout would integrate residential, commercial, and recreational areas seamlessly, enabling a balanced lifestyle. Transportation within the cylinder would rely on electric vehicles and walkways. Given the limited space, urban planning would emphasize pedestrian-friendly designs, reducing the need for extensive travel. The sense of community would be strong, with frequent social gatherings, markets, and events fostering interpersonal connections. While the setting is otherworldly, the essence of daily life retains the comforting rhythms of Earth. Jobs and economy in space. An O'Neill cylinder hosts a diverse economy driven by space habitat needs. Jobs range from healthcare to space engineering and agriculture. The economy blends service, technology, and science sectors. Space farming uses hydroponics and aquaponics. This creates jobs in farming, logistics, and food processing. Maintenance needs skilled workers in engineering and robotics. R&D is a cornerstone, driving innovation. Labs focus on space science and materials engineering. R&D centers attract global scientists fostering learning. The economy is self-sustaining with trade between space colonies and Earth. Section 3. Education and personal development. Education in an O'Neill cylinder would be tailored to the unique environment and future-focused. Schools would integrate traditional subjects with courses on space science, sustainability, and advanced technology. The curriculum would emphasize critical thinking, problem-solving, and adaptability, preparing students for the challenges and opportunities of living in space. Digital and interactive learning tools would enhance the educational experience. Virtual reality and augmented reality could simulate Earth environments, historical events, and scientific phenomena, providing immersive learning experiences. Collaborative projects and research would be encouraged, fostering a sense of community and shared purpose among students. Higher education and vocational training would reflect the needs of the space habitat. Programs in engineering, environmental science, healthcare, and space agriculture would be in high demand. Partnerships with Earth-based universities and research institutions would facilitate knowledge exchange and joint projects, ensuring that the education system remains cutting edge. Personal development would extend beyond formal education. The space habitat would offer ample opportunities for lifelong learning and skill development. Community centers, libraries, and recreational facilities would host workshops, lectures, and clubs, encouraging residents to pursue their interests and hobbies. The emphasis on continuous learning and personal growth would help individuals thrive in the unique environment of the O'Neill cylinder. Section 4. Leisure and recreation. Leisure and recreation are vital for a balanced life in an O'Neill cylinder. The habitat offers various activities for relaxation, socializing, and staying active. Parks provide jogging, picnicking, and outdoor sports, connecting to nature. Sports and fitness facilities cater to diverse interests. Gyms, pools, and courts for various sports are available. Artificial gravity allows traditional sports and inspires new activities. Community events promote health and social bonding. Cultural venues enrich social life with performances and exhibitions. Theaters, concert halls, and galleries support cultural vibrancy. Virtual reality offers immersive experiences and simulations. Cafes, restaurants, and community centers are integral to daily life. These venues provide opportunities for social engagement. Festivals and celebrations reflect diverse traditions. Leisure in an O'Neill cylinder blends familiar and novel activities. A wide range of activities ensures residents thrive among the stars. Living in an O'Neill cylinder involves redefining society. Space habitation necessitates reevaluating social norms and community structures. Collaboration and interdependence reshape societal dynamics. A strong communal identity fosters shared responsibility and problem-solving. Skills and contributions become primary measures of respect. Inclusivity and equity are crucial for social harmony. The cultural landscape of an O'Neill cylinder blends earthly traditions with new spaceborne customs. Festivals and rituals adapt to the space habitat, incorporating unique surroundings. Art and creativity flourish, reflecting life among the stars. Collaborative projects build a shared cultural identity. Multilingualism and new dialects enrich communication. A unique cultural identity honors earthly roots while embracing space life. Effective governance is crucial for an O'Neill cylinder. A localized, participatory form of governance ensures stability and fairness. Regular assemblies or councils foster transparency and accountability. A blend of representative and direct democracy balances management and inclusivity. Laws focus on resource management, environmental protection, and community health. Mediation and restorative justice promote mutual respect. Innovative political models prioritize community well-being and sustainability. Psychological and social dynamics in an O'Neill cylinder differ from Earth. Isolation from Earth can lead to loneliness. Support systems are essential. Strong interpersonal skills and community-building initiatives foster positive relationships. Shared experiences create a strong collective identity. Balanced lifestyles, including physical activity and creative expression, improve mental health. Access to nature, even artificial, is vital for well-being. Proactive support systems ensure a thriving space habitat. Constructing an O'Neill cylinder requires groundbreaking technological innovations. Autonomous construction robots are essential for assembly in orbit. Advanced materials like carbon fiber reinforced polymers withstand space conditions. 3D printing in space revolutionizes large-scale construction. Reusable rockets and efficient propulsion reduce costs. In-situ resource utilization minimizes dependency on Earth. Cutting-edge technologies make space habitation feasible. Radiation and space debris are significant hazards for space habitats. Robust radiation shielding protects inhabitants. Systems detect and avoid space debris. Whipple shields disperse energy from impacts. Debris mitigation policies ensure long-term sustainability. International cooperation manages space debris. Comprehensive protection systems safeguard health and safety. Creating a self-sustaining life support system is critical. Air quality control ensures a constant supply of breathable air. Closed-loop water systems recycle and purify wastewater. Advanced agricultural techniques provide fresh produce. Waste management recycles and repurposes materials. Sustainable practices create a balanced environment. Cutting-edge technologies support long-term space habitation. Overcoming logistical challenges requires meticulous planning. Reusable launch vehicles reduce costs and increase mission frequency. Space tugs facilitate assembly in orbit. Orbital construction yards prepare and assemble materials. Autonomous robotics perform complex tasks. International collaboration shares resources and expertise. In-situ resource utilization enhances sustainability. Humanity's leap into the cosmos. Envisioning life within an O'Neill cylinder is a revolutionary step for humanity. These space colonies represent our desire to explore and innovate, transforming dreams into tangible realities. Constructing an O'Neill cylinder symbolizes our quest for sustainability, addressing overpopulation and resource depletion on Earth, creating new forms of community and culture, embracing the unknown and pushing boundaries. A beacon of hope through collaboration and innovation. Imagine a future where humanity thrives in harmony with the cosmos.